Okay, my friends, let's get into the next series of topics in Math 243, which is just another way of looking at data. We've already seen ways to measure the center of a data set via averages, medians, modes, things like that, and then how the data sets vary. So you might ask yourself, well, what else is there? Well, to answer that question, I'd like to look at one of my absolute favorite applications of our next topic, and it has to do with one of my favorite people in the entire world, our son Max. Now, this is from about 10 years ago at his 2-year-old checkup. Now, when you take a 2-year-old in for their pediatric checkup, they take a few measurements, and here are the measurements that Max got on this 2-year checkup. In his weight, he was the 80th percentile. His length was the 90th percentile, and his head girth, which was my favorite measurement of the three, and they don't do it anymore, which makes me sad, but he was in the 85th percentile for head girth. But what I want you to look at is, look at the numbers, 80th percentile for weight. What doesn't that tell you? It doesn't tell you how much he actually weighs. Just like his length, he's in the 90th percentile for length. So how long was he? He's in the 90th percentile. How about the head girth? His head is in the 85th percentile for girthiness. So you might be wondering the same thing Max is. What do these numbers mean? And why do we even need them? Okay, so what do these numbers mean, number one? And why do we need them, number two? Why aren't averages and standard deviations good enough? Okay, so we're going to deal with that second point first, and then the first point after that. But what I want to talk about real quick, just as an introduction, is what these things are called. Percentiles are a member of a group called measures of relative position, whereas an average or a mode or something like that was talking about the center or middle of a data set. And the measures of variation, like standard deviation and mean absolute deviation, we're talking about how spread out data is. Measures of relative position talk about how data compare to other data in the set. Not to an average, not to a median, but how they compare to each other. So let's dive back in and see why we actually need them, and then we'll chat about what they're actually measuring. Okay, so like I said previously, let's talk about why we need percentiles first, and then we'll talk about what percentiles are actually measuring in the next video. I hear you, buddy, I hear you. Let me start by explaining why we need them. Let's look at how Max compares to his cohort of white American male 2-year-olds. All right, so what I've got here is 100 randomly selected 2-year-old white American males and their body weights in pounds. Okay, why 100? Well, we probably have access to millions of data points. But then I realized millions of data points, it's probably going to make our head spin. Let's go with a smaller number. Why 100? Well, you may have realized that the word percentile contains the word percent, and that's going to be a nice starting point for us in the next video. But that doesn't talk about why we even need percentiles. Okay, let's back up. Suppose I dropped this data set in front of you and said, could you find the average of these numbers? And you would look at them and say, Sean, of course I could. You've taught me how to copy these numbers into Excel and use the average command and figure out that their average is 28 pounds. And I would be very, very proud of you. And then I would ask you the follow-up question. Should we use the average? And that would probably give you pause. And eventually you'd say, you know what, Sean, I'm not sure. Maybe we should take a look at the graph of the data. And when you do, you realize something. This is a bit skewed, isn't it? Your average of 28 sits very nicely in this bar right here. But if you draw a line at that bar and then look at the data to the right and left of it, you begin to realize there's more data to the right than the left. And that's because the median is actually 29 pounds. Now, some of you might exclaim, but Sean, 28 pounds, 29 pounds, that's only a 1 pound difference. Later on in this set of videos, you'll see that when you're talking about a pediatric growth chart for a 2-year-old white American male, 1 pound can actually make quite a bit of difference. We'll come back to that. What I want to focus on right now, though, is maybe we shouldn't use the average or the standard deviation in that case for data like this because it has that idea of skew inherently tied into it. Many data sets have skew. And if they get more and more skewed, we should be more and more suspect of using the average, which is sensitive, as we spoke, to extreme values. So another good way of looking at data like this is by breaking it into chunks and looking at where 10% of it lies, 20% of it lies, 30% of it lies. And that's where relative position comes in. And one example of that are percentiles. Now, some of you may have heard the phrase percentile before, not just through the lens of pediatric growth charts. My pre-nursing students, for example, I believe the TEAS exam is measured not by the score that you get, but how that score compares to other people who take the exam. That's a percentile. So these kinds of measures exist in the world around us in many, many places. In the next video, let's dive in to actually see what these percentiles are.